That, my friends, is a tech order page. Does everybody have their not season Ds, but our tech orders open? Because again, warning and caution. Gotta love those, right? Can everybody hear me?
Yes, sir.
Yes, sir.
Hi, Sergeant McCormick.
Afternoon.
Yes, it is.
I mean, it's a little rainy here. I don't know about
Is it?
in your
It's
area.
been thundering here.
Oh, so you got the exciting rain.
Yeah, all talk, no do. Alright. So let's get this thing started with General Information Chapter 1. Now, you can see general information here. You can see purpose of the equipment here. And equipment description here. But the one place that I always give you guys a heads up on is right here. Types of traffic. You've got two. You'll see that this says it is a 3 volt, come on, 3 volt peak to peak conditioned diphase waveform. Does anybody have an idea what that's really called? Oh man, this class reminds me of, what is it, Ferris Bueller's Day Off, where his instructor's going, Bueller. No one knows what conditioned diphase means. What
It's almost like we talked about that earlier in the block.
What signaling format has transitions? And the only signaling format that has transitions. Let's try somebody I haven't talked to. Airman Rush. Do you have an idea?
No, sir.
How about you, Airman Robinson?
What you say, sir?
Oh boy. I asked, do you know what has, in the signaling format, what has transitions?
Wrong person, sir. I don't know.
Okay, how about Gomez?
I'm not gonna lie.
Hey, at least you're honest.
I'm sorry, sir. I just came from the restroom. What signaling format has transitions?
Mm-hmm.
The not the return to zero. The
Remember that part.
no, I swear it's in the tip of my tongue. It's
the only one that has no.
I know it's the one where it transitions within the same clock. I want to say the bipedal for some reason.
No. Airman Jackson's writing, but while you're stumbling, go ahead. Yes, Airman Jackson got it right. Yes, CDI. Gentlemen, same thing as conditioned diphase. That's it. You're looking at the signaling format, so when we go over these things, not only in the NSM, but you're looking at them at the TSSR, which is GRC-239. So, yes, conditioned diphase. Now, it does carry the 0 to 72, well, 72K to 4608 meg. That's its range. You'll notice that also we have something called analog or digital voice order wire. Well, that's that ancillary channel that we talked about this morning. Let's take a look at this one. You see the 6.144 megabits per second pseudo NRZ. Pseudo. Not NRZ, pseudo NRZ. Let me explain that this will be the only place in the tech order that you will see the word pseudo NRZ. First of all, they can save a bunch of money in having to reprint these pages when it doesn't have an extra word or two. What does that mean? Well, for the company, that could be thousands of dollars in having not to print out one complete page, because that's the way the manufacturer told us. It says by taking that one word out, they saved one page per printout, and they print out thousands of these. And what does it mean by thousands? And everybody's going, well, gee, can't you just put it on a disc and go? Well, that's before this happened. So this is in the 90s. We didn't have digital formats to save this stuff on. So they were actually printed tech orders that you got all paper. And you had to keep them updated, called 8-paged. Once a month, you would probably get in some technical pages that said you needed to upgrade these or line out a word and that, and you would have to initial it and that. It took a lot of work to do that. Nowadays, it's, oh, well, your TO changed. Here's the digital update for it, and you just download it. A far cry from what it is back then versus now. So, and the reason I'm making mention of this is to make sure that you guys understand you might get old equipment out there and you got to accommodate the way it's worded. Okay, so there are 3 things here in this paragraph that you guys need to be aware of. First of all, the CDI, which is the conditioned die phase. Its waveform is from 72K to 4608 meg. You have analog or digital voice order wire. That's our ancillary channel. And then you have pseudo NRZ at 6.144 megabits per second. Everybody clear on that?
Yes, sir.
All right. So there is no excuse when you say, I don't understand this NRZ in Chapter 5. Well, I told you that back in Chapter 1, they're assuming you read Chapter 1 because that's what most maintainers are supposed to do. They take a look at Chapter 1 and then they can take a look at the rest of the book or tech order or tech manual, and they can assume that whenever they say NRZ, it will be pseudo NRZ. Now, we do have some factors in here, and I got to make sure that I can verbally make sure this baseband assembly right here can be MAC rounded on a tripod or on the ground or on a table. Okay. The next one's called an RF assembly because there's 2 assemblies that go with this TSSR. That's the electronic versions. It can be mounted on 3 different configurations. You can put it on a mast, you can put it on a tripod, or you can put it on a pole. Now, this comes with caveats, especially the mast. And we're going to get to that. I think it's Chapter 2 where it shows it. It has, let's see here, remember the 70 megahertz IF? There it is. You have RF radiation that goes out of a 1 or 2 foot dish. And the mast is interchangeable with the one that we have in Block 4. In fact, some of the ones in Block 4 are labeled GRC-239 mast. They're the same mast as a CTM. The difference, they came with the equipment on the TSSR. With that in mind, when you open up the dish box, and it's pretty big, you will see cables, extra cables for the CTM, as well as extra stakes. So when you get into lab, take a look at that. Here we go. Here's that explanation I was talking about. The 1 foot diameter, because you get two. One is a 1 foot, the other one's a 2 foot. The 1 foot diameter can only be attached to the 50 foot mast. The 1 or 2 foot can be on a tripod, or the 1 and 2 foot can be on a pole. The 2 foot acts like a sail and can break the mast in the right conditions. We venture on. Let's see here. It says the mast can be raised to the maximum of 50 feet. Do you need to raise it up 50 feet? The answer is no. You just need to do it in a proper, safe manner. And if it's able to get it at, let's say, 20 feet, do you need to raise it anymore? The answer is no, you don't. Now, with that in mind, it's the RF assembly atop the mast, and I'm pointing out this section right here, down at the bottom of 1.4.2. It says the RF assembly can either be put on the mast, and the baseband assembly is 150 foot in length max with the cable. So there are two cables that come with this equipment. There's a 2 foot to where you can put it on a tripod where the baseband assembly and the RF assembly can be put on there. Or, and take a look at this picture up here. If you see my tisser that's right above the 3/3/8 here in my picture, you will see the RF assembly with the 1 foot dish. Now the baseband assembly has not been put onto that tripod assembly. Now when you put the baseband assembly on it, you only need a 2 foot cable. Now if you wanted to locate your baseband assembly in a nice dry area where you don't have to go outside all the time, then you can put it inside the tent, and as long as you got 150 feet to to the top of that mast, you're good to go. So it's 50 feet for the mast and another 100 feet to wherever you need to roll it off at. This is a case. And I'm going to draw. Well, let's see if I can do it. Can I do it? No, I can't do it. Maybe I can. No, won't let me. There's this little section right here that says 1 over here and a 2 over here. That sounds like a 1 and a 2, right? This is your baseband assembly in a metal case. This is your RF assembly in a metal case. These have a handset. You have in this case, it says a loop back test cable, which we've never seen in one. At least I haven't. How about you, Sergeant McCormick? Have you?
No, sir, I've never seen that.
Okay. Number 4 says it's a 2 foot jumper cable. This is to go on that tripod assembly where you can attach these two, and they're that close. Now this metal case, you're going to be able to pull those out and put them anywhere you need to. Also in there you have a handset and you have a headset. You also have a power cord. Let me explain to you about the headset. Let me give you some safety information on that headset. When you plug the headset in, it looks pretty cool. It's like your gaming headset. However, when you plug it in and you fire it up and someone has left the test tone signal on, be prepared to pull those things off pretty quick because it's going to be loud. There is no volume control for the headset or handset. There is for the speaker. It's a glitch in the system. I don't know why they didn't put one in there. Yep, there's your mast. All right. This is what your RF assembly looks like. Notice the receive frequency at the top here. We get this all the time, that when you enter in your transmit and receive frequencies, everybody thinks that this receive frequency is a transmit frequency and the receive frequency is a transmitter frequency. Please don't get them confused. The next part of this story is the frequency range of our RF assembly, or the TSSR, is from 14.4 gigahertz to 15.25. Let me tell you again. From 14.4 to 15.25 gigahertz. Now, why did I say that? Twice. You see this one right here? And down here? The ones never change. This side right here, the first thumb wheel that you're going to come and play with, it's either going to be a 4 or a 5. If you can put this to a 3, 2, 1, 7, 8, 9, the thumb wheel is broken. We get this all the time where people want to put in the 1 right here. So just letting you know ahead of time. The next part of this story is you have a receive frequency. You also have a receive frequency down here. You're going to use this little knob to vary the different frequencies. This is your pre-selector. This is your overall selection. So please, 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 please get those right the first time so you don't have to go back and change it. You will do your own troubleshooting when it comes to that. This is your baseband assembly. There are what we call 5 LRUs in this one. Let me go up to the RF assembly. I'm getting ahead of myself. There are 3 in this one. This one's easy to determine. 4 of the 5 LRUs. What is a LRU? Line Replaceable Unit. OW means order wire. XMTR means transmitter. RCVR is receiver. These are 3 separate LRUs. Thumb screws right here and right here at the top. You can, once you unscrew them, you can pull out the card assembly. If you are having problems between your RF assembly and baseband assembly, more than likely someone has banged around that metal box where the RF assembly and baseband assembly is and dislodged one of the cards inside of it. You can't get to it. You just got to call it into maintenance. I wish we were the maintenance, but hey, we are classified as instructors. We don't know how to maintain. Right, Sergeant McCormick?
I'm inclined to disagree with that.
Yeah, I
very much know how to do maintenance.
I've been doing maintenance what it seems like my whole life. Anyway, this power assembly has 2 LRUs. It actually has the breaker panel, which is right here, and back behind it is the power supply. It gives us our DC voltages to the rest of the radio. So there's 2 in this one and 3 in the other one. And we get that a lot, that when you're banging around that equipment, it is heavy, and it's acceptable that you know, on occasion will mistakenly drop it. I've seen it dropped off of the tripod assembly. I've seen it just fall off of the metal case a couple times, and it will dislodge the cards in the right conditions. So please, if you drop it, let the instructor know, hey, I dropped it by accident. Then you can check out the, if it works, we're good to go. The card stayed seated in its, oh geez, I'm trying to think of the darn word for it. Kind of like the D connector when it fits into its jack. There we go. All right, this on table 1-1 is the leading particulars. You can look at the actual radio set right here, which is the GRC-239. We have the RF assembly at 16.5 pounds, gentlemen. That is one heck of a weight to lift above your heads on a CTM-15. It is heavy. Capabilities and limitations 1-7, which is table 1-2. Here's your frequency range. Here is your output. Now this is out of the RF assembly, because if you look down here, this is what the RF assembly is doing. So frequency range and how much power output. Here is your IF frequency at 70 megahertz. Here's your baseband assembly. Then you go on to the antennas. When you have an output of 25 dBm at 316 milliwatts, when you add the 1-foot antenna, it goes from 25 to 31. You have a 6 dB of gain. 6, mind you. When you add the 2-foot, it becomes 37. That's 12 dB of gain. All by doing one thing in attaching a waveguide to it with the parabolic dish. How far can the dish go with the 1-foot? I'm pointing this out to you, gentlemen. You see that little sign in front of the 10?
Yes, sir.
Yes.
And you see the little sign in front of the 25?
Yes, sir.
That means it's less than 10 miles and less than 25 miles. Not to say 10 and 25, okay, in an approximate value, but that's the way they classify that. Here's your 2-foot jumper cable. Just wanted to point that out. Here is the antennas. Now you're going to see something called a waveguide. The 1-foot antenna actually has a small waveguide. The 2-foot antenna has the larger waveguide. So make it more directional. And you can go through the rest of this at your pleasure. This is the installation. I love this. Section right here. Come on. There we go. You are looking for latitude and longitude when you get a crew sheet. You're going to be getting a cut sheet as well, but you're not going to have to do the azimuth and what we call elevation like you would the transit on the AV 2011. This one, we're more interested in getting you guys operational. As long as you point the antenna to each other, it should be good. But when you get out in the field, you're going to have to use your azimuth and elevation in order to get the RSL to work properly. You might have to tweak the dishes in order for it to work properly. And again, contents of the transit cases, because that's what you're going to be seeing out there. I always like going over this part. Tripod, mast, and pole. Gives you some man hours with it. It changes. When you're in lab, you have approximately, I think, 45 minutes. Correct me if I'm wrong there, Sergeant McCormick. 45 minutes to set up the tisser or make contact. To do all your checks in it?
That's block 10 in
block 10 is 15
30
minutes.
30 minutes, I believe. I'm sorry. I think they changed it recently when they switched the SCLAs.
Okay.
Yeah, and for block 7, they get 45 minutes.
Okay, 45 minutes. So when you get 45 minutes, that means that you've got to put everything together, go through your checks, and make communication. And it's pretty easy to do. The first couple times might be difficult, but when you get into block 10, you're going to have a little bit easier time because they're going to give you the chance to put in all your frequencies, do your check before you go out there and set up. with that in mind, you're already gone and put your frequencies in. You've done your checks, pack everything up. Then you go out there. The only thing you got to do is set it up, make comm. Most of the time, you guys are hustling and get it done in less than 5 minutes, which makes it easy on you guys and can help everybody else out in getting their UTCs up and operational. Oh boy, this brings back memories, doesn't it? How to hook up your cables, put on the reel. Ah, yeah. Chapter 4. This is where you will be doing your checks. What they have done is taken this information out of Chapter 4, Chapter 4, and put it in a extract so you don't have to go through all the paperwork to see this. And again, this part right here. Whoops. Rotate the 4 transmitter thumb wheel switches. And that's what they're talking about, these 4 thumb wheels. And you have a receiver switch. Now, I want to get into the RF assembly controls and indicators, table 4-1. Anything and everything you need to know is on this table. Again, I'm pointing out to the 10,000 megahertz is a screen printed 1 on the front panel. The thousands are either 4 or 5. So it just goes to show you, that says 1,000 units on the megahertz. That means the 1's gigahertz. And it has it also on the transmitter frequency. So I've shown you in a couple places here where you don't want to go ahead and try to put a 1 in what should be either a 4 or 5 and break the thumb wheel if it's still there. Channel error light is always a fun one because you can go out of range. For example, if you fired this thing up, you get ready to transmit, and all of a sudden, hey, this red light's on, and it says channel error. That means that you've either below 14.4 gig or above 15.25 gig. It can happen. Simple thing like accidentally flipping the thumb wheel one too many. This is your baseband. And all these assemblies, the controls and indicators. You got a meter on both of them to give you any type of status you need. And there's our baseband assembly. I know this is all boring, but if you don't pay attention to this, you're going to have some problems. Next up, theory of operation. This is what we're getting ready to go through. We're going to go through the transmitter, receiver, kind of a quasi-intercom, and loopback testing. We don't go through the built-in test tools because it's pretty obvious because it's the indicators and sometimes a tone. So it just gives you an idea of what we're going to be going over. And the transmitter operation is the first part. We go through that. We're going to be going through the C's and D's, so start breaking them out. And we also have the receiver operation right here. Again, each one of these has a general description, a block diagram, and then it goes through each one of them. And if you get into a question on the appraisals that you need help with, please do not hesitate to message me on Discord. I will do my best to answer it. We can either do regular text chat or voice chat, either way. We have... Go ahead.
I'm sorry, just a question, kind of unrelated, but will these videos be available to us as well, or?
When you say videos, the one I'm recording?
Yes, sir.
Yeah, I put them on RF transmissions, and if you were to go above, let's see, my last statement, you'll see that there's one of those videos in there, which we went over 1 Alpha and 1 Bravo, if I'm not mistaken. And then the afternoon, Sergeant Young had you, I think,
Yes,
for
sir.
the 20th. Now, he didn't record it. I always record it. So today when I get off, I'll be quickly editing and putting it on the RF Transmission YouTube page, and I will link it in your chat. So that way you have a backup just in case you miss something.
Yes,
I do
sir.
it
Thanks,
for
sir.
every class. I try to help you out as much as possible. And if you wanted to, link to the RF Transmission webpage, there are reviews in there and appraisal reviews. So just to give you an idea of what we do for you and trying to help you out. Okay, in Chapter 5, okay, we went over that. So when we look at, yes, I want to close that. And no, I don't want to save it. We're going to go back to our objective for Charlie. And I will be asking questions here because some of this came from the last couple objectives that we had this morning. So we're going to identify basic facts about the characteristics of tropospheric satellite support radio. Oh, man, that is a mouthful. Better known as a TSSR. TSSR to GRC-239 are interchangeable, so if you talk TSSR me, I will understand what you're saying. There is I would probably say a 90% chance of you seeing a TSSR out there. There are still some organizations out there that have it, but they are not being deployed with it. It is being replaced by the P2P, but in the meantime, that's what you've got out there. It takes a long process for everybody to get these items. We're going to look at the purpose of it, the operating characteristics, types of the traffic, equipment, signal flow. So let's take a look at this one. It says full duplex line of sight radio terminal. What does that mean by full duplex? Let's try Brownback. What does it mean by full duplex?
It means that it can both transmit and receive at the same time.
Good. What is half duplex?
It can only do one at a time.
Okay. What is simplex?
It can only go one way.
You do know that there's more information on that, right?
Yes, sir.
Okay. Let me try to give you some more information. All right. Simplex, like you said, is one way. It's also one frequency. Half duplex is two frequencies. It's either transmit or receive. You can't do both. Full duplex is two frequencies and you're transmitting and receiving at the same time. This is how it's going to work for the TSSR is you're going to have two separate frequencies that is full duplex because of the two frequencies to keep from interfering with each other. And that goes back to that frequency diversity that I was talking about earlier where you have 200 megahertz apart between the two. Kind of amazing. At least I'm amazed by it. Next up, this comes straight out of your tech order. Here's your frequency, your power, your IF frequency, max range, less than 25 miles. Your three different types of traffic, CDI, NRZ, Those are the two signaling formats. And then you have the analog and digital voice order wire, which are adjacent channel or an auxiliary channel for us. There are two assemblies. You can definitely tell. I think, when did we stop wearing those uniforms there, Sergeant McCormick?
That would be 2011.
Yeah, in fact, I just moved my old BDUs away to get this shirt. Had to move them and realized, crap, these are old. Okay, you have the baseband assembly. It can go in a couple different places. 19-inch rack, tripod, flat surface. The RF assembly can be either on the 50-foot mast, tripod, and pole. Garcia, which one of the dishes can you not mount on the RF assembly on the mast?
Yes, sir.
I saw you key up, but I didn't hear you. No idea? Okay, you're typing. Not sure. Can you help him out there, Airman Basisco? Forgive me.
Sorry, so you said the dish that you cannot mount on the mast?
That is correct. It's a 50-50 chance. It's either the 1 foot or the 2 foot.
Can I go ahead and say it's the 2 foot?
That is the one you cannot mount on the mast. You can with a tripod and pole. Yes, that is a correct answer. We have the baseband assembly. This is a better picture of it. As you can see, we have 5 LRUs. On the RF assembly, we have 3. You can use the 1 or 2 foot antenna. That's that picture right above me, above the 338 there. That is the 1 foot dish along with the 1 foot, well, I think it's like 8 inches for the waveguide. You mount the waveguide either horizontally or vertically polarized. You can attach the baseband assembly, either the 2 foot cable if it's on a tripod or the 150 foot cable if it's located elsewhere. That's the last thing you want to do is unroll a 150 foot cable and trying to attach it from the RF assembly to the baseband assembly when it's on a tripod. Doesn't make any sense. Unless you forgot the 2 foot cable or the 2 foot cable is broken. Then it would make sense. You have the transmit and receive must be at least 200 megahertz apart. That's also right out of the tech order. I failed to show that to you. That is your frequency diversity too. Here's the antennas it comes with, the 1 and the 2 foot. Here's the 1 foot and how much more gain you're going to get out of it versus the 2 foot. You're going to get more out of the 2 foot, but there's, again, you can't mount the 2 foot on the mast. Transmittance and receive signal path along with standby loop back. Now, this is a long section. We are going to postpone this till tomorrow morning at 9 o'clock so we can get along or we can go through this. It is a very good chance that tomorrow morning will be the last part before you go to lab if we are able to cover all of 4 Charlie. We've covered some of 5 Alpha and 5 Bravo is the actual lab. So I'm going to stop it here. That way I give you guys some breathing room and you're not overwhelmed, because this is going to get intense, gentlemen. I'm going to be pulling this stuff out of Chapter 5, so I suggest very highly that you at least go over Chapter 5 and not read it, but just scan through it to get an idea of, oh, this is what we're going to be looking at. Oh, okay. You might want to also pull out your schematics and see if you can follow along. If you can't, that's what I'm going to be doing tomorrow, is we're going to go through this. Is there any questions on what we've covered today? Anything from this morning or this afternoon?
None, sirs. Just one last thing I wanted to ask about the videos, because I
Sure.
see you have videos already set in your channel here for Block 7 already. I'm not too sure if those are out of date per se, or if...
Well, if you take a look at them, the later ones are more in depth. The earlier ones, we were trying to fill things out, like the let's see here, like the 20th April. That was our very first stream, and we didn't really have a grasp on what was happening. I would probably say Class 22 is by far the best one so far. But, yeah, I'll get to that in just a minute there, Jackson. But on the other end of that stick, you know, you're going to have this one too. So if you want differences between the two, go and look at Class 22, starting the 15th of May. And if I'm not mistaken, I put the date on there, and it's also covering the same objectives that we did. You might be able to understand it a little bit more or less, depending, you know, what you want to get out of it. You also have the one that I just posted above you. So those are some pretty good references. But the 15 May for Class 22, the 18th of May for Class 22, I think the May 19th is the appraisals, and 20th of May is the review for that class. And we're going to be doing the same thing, so you guys get individualized attention, so we're not shirking our responsibilities as an instructor, because that's what it is. Because some questions you may ask versus what they ask are two different sides of the coin here.
Yes, sir.
The goal is to get you guys as much information as possible to pass this block, because it is one of the toughest ones out there. Sergeant McCormick can attest to that.
Yeah, I would definitely advise studying a good bit for this block.
Well, you got a weekend before it happens. All right, so Aaron Jackson's wanted to know what pseudo NRZ is. So I point you to the word pseudo. I always like to say pseudo is it's kind of like NRZ, but it really isn't. When I did the research on pseudo NRZ, and I looked it up on Google, what it appears to me is it does the opposite. Like a logic level 1 is actually a 0, and a 0 is actually a logic 1 when we look at regular NRZ. And the only reason I can think of this company was using it is because the guy who got the quote-unquote master's degree in electronics did his thesis on it, and they adopted it. I guess he convinced them, and that's what it is. Because it's his paper that I found. And it was, you know, his company was the one that adopted it. At least that's what I can gather from the story. I know it's kind of not what you wanted to hear, but that's what I have found. And again, you can look up pseudo NRZ. When I did that for Google, that's where it pointed me. And that's what I can pull out of the information that I see. Hopefully that answered your question here, Jackson. It is NRZ that looks different in the way the logics are drawn out. Any other questions? Any concerns?
No, sir.
Sir.
All right, I'm going to turn you loose. You guys have a wonderful day, and we'll see you back at 9 o'clock to go over the schematics. All right?
Yes, sir.
All right, have a wonderful day, guys.
Thank you, sir. You too.
All right.